So, next we are going to discuss about a what? Method based on a finite difference operator, means how we find the values of a different order derivative at x equal x0, at x equal xn, at x equal middle points. As we say that in case of a equal class interval, if we try to find out the derivative at initial point, at a starting point, then we use the forward, at last point, then backward, at central point, at central value, then we use the central interpolation formula. So, next one is a what? Next one is a how we derive these formulae, means in a method of undetermined coefficient also we derive these formulae, and in case of a method of based on a different difference operator, we also derive these formulae. So, once we see how we derive these formula using the different difference operator. So, here we write what? Here we write a method based on difference operator, difference operator, method based on difference operator. So, as we know that what is the relation between E and del, we know that del fx equal what? Del fx equal f of x plus h minus fx. So, if we write this one, del equal what? Del fx equal E of fx minus fx. This means del equal what? Del equal E minus 1. Del equal E minus 1. This one is a one relation, and one other relation is a what? One another relation is a relation between E and D. So, we know that the Taylor series expansion of a f of x plus h is a what? F of x plus h f dash x plus h square upon factorial to f double dash x and so on. We may write this one as what? We may write this one as fx plus h d of fx plus h square d square of fx upon factorial 2 and so on. So, we may write this one f of x plus h equal 1 plus h d plus h square d square upon factorial 2 and so on up to infinite number of a term of a fx, and this can be written as a e of a fx, and this one is written as a what? This one is written as a e to power h d of a fx. So, what is the relation? Relation is a, from here we find what? We find the relation what? We find the relation equal what? Equal e to power h d. So, these are the two relations that we are going to use. We are going to use this relation and this relation in order to find out the value of a what? Value of the derivative d, because d is a what? Differential difference operator. D is a differential difference operator. So, what will happen here? So, from first and second, if we write here, from first equal what? Equal 1 plus delta, 1 plus forward difference, and from second what will happen? E to power h d become what? 1 plus forward difference, e to power h d equal 1 plus delta. Then this implies that what is the h d? H d become what? H d become log of 1 plus delta, log of 1 plus delta. So, if we expand this one, then h d become what? H d become, this one is a del minus del square by 2 plus del cube by 3 minus del to power 4 upon 4 and so on and so on. So, this one is a what? This one give the value of the derivatives. So, if we expand this one, then what is the d? D become 1 upon h del minus del square upon 2 plus del cube upon 3 minus del 4 upon 4 and so on. So, if we find at x equal x0, then d derivative of fx at x equal x0 then this become what? D of fx 0 equal f dash x0 equal, if we operate here f of x0, if we operate the f of x0 here, 1 upon h, this become what? Here we operate f of x0, then here we write a del minus del square upon 2 plus del cube upon 3 minus del 4 upon 4 and so on up to infinite number of a term. Here we operate the f of x0, then what will happen? This will give the what? This will give the, if we denote the fx0 equal to y0, let fx0 equal to y0, then d of y0 equal f dash x0 equal 1 upon h. This become del y0. If we operate this function, then this become 1 by 2 del 2 y0 plus 1 by 3 del 3 y0 and similarly minus 1 upon 4 del 4 y0 and so on. So, this one is a way how we derive. If we compare this one with the derivation that we derive with the help of a what? With the help of a forward interpolation formula. So, here we erase out this one. So, here if we closely observe this one, this relation then this relation and the formula that we derive with the help of a what? With the help of a difference operator. So, this one is a what? Both the equation, both the expression is same. So, this one is a way, means either we use the method based on a interpolation, or we use the method based on a difference operator, or we use the method based on a undetermined coefficient, we able to find out a same formulae. So, same formulae means this one. So, here we derive the formula for the forward interpolation. Similarly, in a similar manner, we able to derive the formula for the backward interpolation. So, here we are going to write what? We are going to write the value of a derivative at x equal x0 using the forward interpolation formula, and the value of a derivative at x equal xn with the help of a backward interpolation formula. Means I am not going to derive the backward interpolation formula directly, we write the backward interpolation formula, then we solve a one numerical example. So, because the derivation is similar to the forward interpolation, you can use the relation between backward interpolation backward difference operator and HD. Means here we write what? Here we write what? In place of E, what is the relation between backward and shift operator? What is the so this one is I think we move on a next phase. So this one is a method based on this one is a not. So that we derive here. Means from here you may also able to find out a what? You may also able to find out a relation between backward and shift operator. Then what is the relation? Relation become del fx equal f of x minus f of x minus h. F of x minus h. This means del equal 1 minus E inverse. So this one is a means what is the E? E inverse become what? E inverse become R1 upon E equal 1 minus, this one is a 1 minus del and E equal what? Equal 1 upon 1 minus backward difference operator. So if we use this relation with the help of E equal e to power sd, then we able to find out a what? Then we able to find out a formula of a derivative at x equal xn using the backward difference operator. So now we are going to write directly the formulae. So here we going to write the formula for the formula using the forward interpolation formula for the using the backward interpolation formula. So here we write a what? Y dash equal f dash x0 equal 1 upon h. Here we write a what? Del y0 minus 1 by 2 del 2y0 plus 1 by 3 del 3y0 and so on. This one, and second order derivative be the y double dash equal f double dash x0 equal 1 upon h square. This become del 2y0 minus del 3y0 and so on. This one, and similar manner, what is the differentiation? Yr equal fr x0, this become 1 upon hr. Here del r y0 minus r by 2 del r plus 1 y0 plus r 3r plus 1 r 3r plus 5 divided by 24 del r plus 2 y0 and so on. Okay, this one is a backward this one is a forward interpolation, forward using the derivative using the forward interpolation formula. Similarly, we may also able to write what? Backward interpolation formula. What is the backward? Using the, this one is a derivative using forward interpolation formula. Derivative using the forward interpolation formula. Similarly, we able to write a derivative using backward interpolation formula. Backward interpolation formula. So what is the difference? Difference become what? Here we write first order derivative y dash equal f dash x0 equal 1 upon h. This become del y0 plus 1 by 2 del 2 y 0 plus 1 by 3 del 3 y 0 and so on. So, and what is the second order? Second order similarly y second order become f double dash. This one is a not here we write not in term of y 0, because this one is a not you can not say this one is a y 0, because you are going to write a what? You are going to find out here we write a del backward difference operator. So, we delete all the terms here. If we delete this one and again write here y dash equal f dash xn, because we find with the help of a backward interpolation formula at the end points. F dash xn equal 1 upon h, first term is the del n. So, this one is a what? Del yn minus 1 by 2 del 2 yn and plus 1 by 3 del 3 yn and so on. And second, here not a minus, this one is a plus, sorry, y double dash f double dash xn equal 1 upon h square, this become del 2 yn plus del 3 yn and so on. If we generalize this one yr equal fr xn equal 1 upon h to power r del r yn plus r by 2 del r plus 1 yn plus r 3r plus 1 upon 24 del r plus 2 yn. So, this one is a way. This one, these formulae for the forward and these formulae for the backward interpolation formula. We find derivative at x equal x0 and x equal xn. So, what is the summary of our derivatives? How we find the derivatives? If we try to find out the derivative at the initial point or the starting point or near to the starting point, then we write a forward interpolation formula and find the derivative. And or directly we write the formula of a derivative at x equal x0 or general formula of a derivative. And if we try to find out near to the last value, then we write a first backward interpolation formula and find the derivative, or directly we write the formula of a derivative at x equal xn or general formula of a derivative for the backward interpolation formulae. With the help of a backward interpolation formulae means first we write a formula and putting the values of del y0 del 2 y0 means a different order of forward differences at y0 at yn, then be able to get the values of derivatives. Similarly, if there is an unequal class interval, then directly we write the Newton divided difference formula or Lagrange interpolation formula and find the derivative, and then putting the values with the help of a divided difference table, or directly in case of a Lagrange interpolation formula directly the putting the values of x means nodes and its values, then be able to get the values of derivatives. So, now